Hi. The computers as we see today evolved with time, obviously. They started probably with some mechanical devices like the analytical engine. They went on to have some of the valves based computers. These valves are what we call as the forerunners of the transistor. They were vacuum tubes which generated electrons, and the electron which was generated could be used to perform some logical calculations. And of course, the input devices and output devices are nowhere what we see today. So, when we look at a computer, basically, it's a collection of gates, a collection of gates, as in logic gates. So, leaving the physics out of the whole thing, you'll find that a computer processor essentially can do certain operations based on their instruction set. So when you write a program, you essentially use a software which helps you model the processor and do some work. So what are the steps which you can do to get a desired output? So this is probably what we call as the algorithm, and this should be compatible with the machine which you are writing the program for. If you see here, this is a very simple 386 machine. This is the forerunner of this is probably the first 32-bit computer which was made available. 32 bits means that each word or each character which you can pass from the user to different parts of the computer and the output device could work with 32-bit of word length. So this word length and other things and character set will be seen in a subsequent video. And for now, you can imagine that a 32-bit machine is having much more capacity than a 16-bit machine, and much more than an 8-bit machine, so on and so forth. Now, if you look at the inside of a computer, you'll find that there are discrete transistors that we have to make it to work. And trying to wire up every time these devices is not an option. The basic part is the digital logic, the NAND gates, NOT gates, flip-flops, and other things which you have been working on with in your physics. This is tied together by some embedded programs. So these programs cannot be changed, and this forms the basic instruction set. So when one of the instruction set is being used, the sequence of commands which have to be fired so that the right transistors work are set in place. Now this is also a very difficult way to communicate to the computer. So we have what are called as the operating systems. So the operating system does the job of translating any instruction which a program gives to what the underlying hardware can understand. This underlying hardware has its own instruction set, has some fixed paths which it will take when a particular instruction is received. A little above that is your high level or assembly code, which we call it, because the assembly code can talk with the operating system. So this is usually your compiled programs. So when you go to Java, you write a program which is a Java program which is converted to a byte code. The byte code is made for a virtual machine. Now, what is made by the virtual machine is moved into the assembly language essentially. So the assembly language, the Java virtual machine knows how to send the correct assembly language code to that particular operating system or the particular architecture we are speaking about. So if you look at the assembly language, even that is a little difficult for us to remember. So when we want to use a more human level of language, we use the high level language. In this case, we are going with Java. We can go with Python, we can go with C, C++, and so many other languages. So Java is the language which we are speaking about now. It's something which we can understand. We give a set of instructions to do something in a logical manner. And whatever is the output of our code, whatever is being run is actually to be used by an end user. So we need to look at the end user's ease when we write programs. And in conclusion, I will say that once you start to type out a program, this program is sent to a compiler, which makes it a little more computer friendly. It compiles it into assembly code, which the operating system takes and passes it down to the underlying hardware. And whatever is the results of processing by the underlying hardware, it sends it back to the place which the user is asking it to go to. So with this, we will stop this session, and I hope you found this information useful. So bye for now.